So today we're going to pick up where we left off yesterday. And yesterday we created an Actix server using the Tokyo runtime, which allows us to make the main function asynchronous. We created the Actix server in a library file and exported it as a public run function. This was so that we can test it. And in our tests folder from yesterday, we had a health check test where we created a spawn function and then we hit the health check URL endpoint and ensured that it responded with a 200 all is okay response call. So today we're gonna try and extend the tests, and we're gonna write two integration tests that go in health check under tests. So if we go to day 29 and we go to health check, then we have two tests. One is for a valid form with a name and email. Once that's submitted, you get a 200 request. And then we want, if it's not submitted, like if the fields are missing, it should fail. So we need a bunch of dependencies that you want to install. I've already installed them, but this will be a fresh build for you. So once you've installed those, let's have a look at the test. We use our spawn function, same as the one we used yesterday. Create a new client with request, which is the equivalent of a fetch handler or Axios from JavaScript. Then we URL encode the body, which is a bit complicated, but that's where we are. And then we send a post request to the endpoint with the app address that we spawned. And then we add our headers, and then we add our body. And because this is a test, we are mocking out the body. Then we await the call and we assert a 200 request. Similar thing for the no data fails the test, except we're creating a table, like an array with test pairs. So this is called a table test. So we're saying if it's just the name, then it should say missing email. If it's both, then it should say, or if it's just the email, then it should say missing name. Or if it's neither, then it should say missing both. And then we run a for loop. And we do a very similar call as the last test, except this time, because it's in a for loop, we iterate over the table that we just created. And we want to make sure that it fails in each scenario. So if we go cargo test, we should see that both tests fail. And that makes sense because we wrote the test, but we didn't write any of the implementation. So let's go to step 2, which is going to be in the library file. Step 1 is in health check. Step 2, let's comment this out. So all we're doing in step 2 is that we're creating a new handler for a new endpoint called subscriptions. So we add a route for subscriptions, and then we add the handler, which at the moment just returns 200 regardless of the input. So let's try the test now. Let's save the file and try the test now. So now we get 1 passed, 1 failed. So the returns a 200 for valid form data passes. And the reason is because we're saying that regardless of the input, this test should pass. But luckily it's failing the 400 when it passes in the wrong data. So progress, but let's move to step 3. Now in step 3, we need to create a struct, which is like an object that stores the information that we want to deal with. In this case, it would be form data. And we have to serialize the information from the URL encoded information that we're getting from the server. So think of this as JSON stringify, because when you send data over a web server, it needs to be in a string format. So you can't like just send an object, you stringify it, and then you JSON parse it. Serialization and deserialization is handled with this package that I still don't know how to pronounce. I'm going to go with Serd like merd. So this is a serialization package, but it doesn't handle deserialization. You need to add a crate for the specific type of deserialization you want. So if you want to if you want to deserialize JSON, or if you want to deserialize to CSV, you need to install separate crates. Serd is just its own kind of base crate for the serialization and deserialization process. We've already covered all of this in the JSON parser day 13 lesson, so you should be familiar with this. Just wanted to remind you that you have to add the, what is the word for this? I forget this. Trait? No, it's not a trait. Implementation. This thing above the struct, which is not a comment. Anyway, that's it for step 3. So let's move over to step 4. The whole point of adding this form was so that we can then interact with it. And this interaction happens via this new ability that we get, web form, which comes from Actix. And Actix is doing a lot of the heavy lifting using the URL encoded deserialization package in Serd. So we don't really have to worry about this. Like, Actix is doing a lot of the heavy lifting for us. We add the root and we say, hey, pass in subscribe. And then when we pass in subscribe, we're saying that the input comes from form data, and form data automatically hooks up to a struct that we give it. So now when it gets information, it will store that information in this struct. And if we run cargo test, it will say that the fields in the struct are not being referenced anywhere, so they're dead code because we're only referencing them in the test and it doesn't see the test, which is fine for now. But other than that, we get 2 passing tests. So everything is good. If we go back to the test file, you can see that we haven't changed the test in any way. That's how we write integration tests and then add root handlers that handle form data. See you tomorrow.